Imagine a man who looked up at the night sky, not with wonder alone, but with the cold, burning precision of a mathematician. A man who dared to ask, what if the flat rules of geometry mean absolutely nothing on the surface of a sphere? That question, that single earth-shattering question, would crack open an entirely new branch of mathematics. And yet, most people have never heard his name. His name was Menelaus, and this is his story. Welcome back to Numbers and Narratives by Blessright, the channel where the greatest minds in the history of mathematics and science come alive, not just as names in a textbook, but as real, breathing, struggling human beings who changed the world. I am so glad you are here today, because what we are about to uncover together is one of the most underrated stories in the entire history of science. If you are new to this channel, welcome, friend. Hit that subscribe button right now and turn on notifications, because we drop stories like this one regularly, and you do not want to miss a single one. And for those of you who have been with us, you already know what we do here. We do not just skim the surface. We go deep. We go human. We go real. Now, before we go any further, I want to tell you something important. At the very end of this video, I will reveal a striking, almost unbelievable detail about Menelaus and his legacy, a detail that most historians gloss over, a detail that will completely change how you see the survival of human knowledge. So watch until the very end. Do not skip ahead. Trust me, it is worth it. Now, let us go back, all the way back. The 1st century of the Common Era. The Roman Empire is at its height. Caesar Augustus has already died. Tiberius, Caligula, Claudius, Nero, they have all had their turn on the throne of the world. Rome is the beating heart of civilization, or so the Romans believe. Roads stretch from Britain to Babylon. Trade routes carry silk from China, spices from India, grain from Egypt. The world is, for the first time, something close to connected. But beneath all the politics, beneath the wars and the conquest, something quieter and infinitely more powerful is happening. In the great city of Alexandria, in that extraordinary, irreplaceable jewel of the Mediterranean, scholars are doing what scholars have always done. They are thinking. They are measuring the stars. They are calculating the paths of planets. They are drawing triangles on parchment and asking questions that would not be answered for another 1,000 years. It is into this world, this extraordinary electric world of Greek philosophy melting into Roman power, of Egyptian tradition feeding the fires of Alexandrian curiosity, that a man named Menelaus of Alexandria enters history. Before we talk about Menelaus himself, we need to understand the city that made him. Alexandria. Founded by Alexander the Great in 331 BC, this city was designed to be the intellectual capital of the world, and for centuries it was exactly that. The Great Library of Alexandria, at its peak, held hundreds of thousands of scrolls. Scholars who worked and studied there included Euclid, the father of geometry, Eratosthenes, the man who calculated the circumference of the Earth with astonishing accuracy. Archimedes spent time there. Hipparchus built his star catalogs there. Hypatia would later teach and die there. This was not just a library. This was the living brain of an entire civilization. And it was here, in this city of light and learning, that Menelaus was born, around 70 AD according to scholarly consensus and the internal evidence of his surviving works. He breathed the same air as giants. He walked the same streets where Euclid's Elements had been read for 3 centuries. Every stone in Alexandria whispered mathematics, and Menelaus was listening. What do we actually know about Menelaus the person? Here is where history both gives and takes away. The honest answer is this: we do not have a biography of Menelaus. We do not know what he looked like. We do not know if he had a family. We do not know his exact birth date, and we do not know precisely when he died. But we are not without clues, and those clues are precious. The Greek astronomer and mathematician Claudius Ptolemy, one of the most important scientists of the ancient world, mentions Menelaus by name in his landmark work, the Almagest. Ptolemy records that Menelaus made astronomical observations in Rome. Specifically, Ptolemy references 2 observations Menelaus made in Rome, one on the 14th of January in 90 AD and another shortly after. These were careful, precise recordings of the positions of the moon and certain stars, most notably the occultation of the star Beta Scorpii by the moon. Think about that for a moment. Menelaus was in Rome, the capital of the empire. He had traveled from Alexandria. He was known well enough that Ptolemy, writing decades later, considered his observations worth citing. This tells us Menelaus was not a fringe figure. He was recognized. He was respected. He was known across the Mediterranean world of scholarship. His name also appears in the writings of Pappus of Alexandria and Proclus, 2 later mathematicians who reference him with clear reverence. He was, in the language of his time and ours, a giant. Now we come to the heart of everything. Menelaus wrote several works. Some are entirely lost, but one survived. And that survival changed the course of mathematics. The work is called the Spherica. It is a treatise in 3 books, and it is, by the consensus of historians of mathematics, the earliest surviving work dedicated to spherical trigonometry. Let that sink in. Before Menelaus, mathematicians had geometry on flat surfaces. Euclid had given the world his Elements, that majestic system of flat-plane geometry that still echoes in every high school classroom today. Lines, triangles, circles, on flat paper, on flat ground. But the sky is not flat. The earth is not flat. The paths of the stars, the moon, the sun, they do not move across a flat board. They move across a sphere. They curve, they bend. And if you want to understand the heavens, you need geometry that curves with them. This was Menelaus's breakthrough. He asked, what happens to the rules of geometry when you put them on the surface of a sphere? What is a triangle when its sides are not straight lines, but arcs, curves along the surface of a globe? In Book 1 of the Spherica, Menelaus systematically develops the properties of what we now call spherical triangles, figures drawn on the surface of a sphere with sides made of great circle arcs. Great circles are the largest circles you can draw on a sphere, like the equator or lines of longitude on the Earth. He proves theorems about these spherical triangles in a way that directly parallels Euclid's work on flat triangles, but stretched onto the surface of a globe. This was not just clever, this was revolutionary. This was the foundation of a brand new discipline, spherical geometry, which would eventually give birth to spherical trigonometry, the mathematics behind navigation, astronomy, and much of modern physics. Book 2 of the Spherica applies spherical geometry to problems in astronomy, calculating the positions and movements of celestial bodies. This was the practical engine of his theory. Book 3 contains what many consider his single greatest contribution to pure mathematics. In Book 3 of the Spherica, Menelaus states and proves what we now call Menelaus's theorem. Now, I want to be very honest with you here. This theorem exists in two forms, one for flat triangles and one for spherical triangles. Both are profound. Both bear his name. Let me describe it in plain human language. Take a triangle, 3 points connected by lines. Now draw a straight line that cuts across the triangle, crossing 2 of the sides, or their extensions, and one of the third side's extensions. Menelaus proved that there is a precise, beautiful, inevitable mathematical relationship between the 6 segments created by that cutting line. Specifically, if you multiply 3 of those segment ratios together, alternating around the triangle, you always get exactly -1. Or, in the positive formulation, the product of the 3 ratios equals 1. Always, no exceptions, wherever you place that cutting line. Now here is something important that scholars debate. Did Menelaus invent this theorem from scratch, or was he codifying something already known in less formal ways? The historical consensus is that Menelaus was the first to state and prove this theorem rigorously, particularly in its spherical form. The flat version may have had earlier informal precursors, but Menelaus gave it the structure, the proof, and the precision that turned it from an observation into mathematics. And for spherical geometry? His spherical version of this theorem was entirely new territory. No one had gone there before him, not in any surviving record, not in any text that has come to us. This theorem would later become one of the foundational tools of Islamic astronomers in the golden age of Arabic science. It would be used to calculate the direction of Mecca from any point on Earth, a calculation with profound religious and practical importance in the Islamic world. A Greek mathematician from Alexandria, writing in the 1st century AD, unknowingly giving Islamic civilization one of its most practical mathematical tools. History is extraordinary. Menelaus was not just a theorist locked in a library. He was an observer. He went out at night. He looked up. He measured. We know from Ptolemy's Almagest that Menelaus made precise astronomical observations in Rome, at least 2 of which Ptolemy recorded and used in his own calculations. These observations, made around 98 AD, involved recording the exact position of the moon relative to specific stars. One observation, recorded by Ptolemy, documents Menelaus watching as the moon moved to occult, that is, to cover and hide the star Beta Scorpii. He noted the precise moment, the precise position. This was careful, disciplined, scientific work. But Menelaus went further. He also wrote a work called The Book of the Elements of Spherics, a more elementary treatment, designed, it seems, to make his ideas accessible to learners. He also reportedly wrote on the calculation of chords, an ancient precursor to trigonometric tables. And there are references by later scholars to a work by Menelaus on the specific weights of metals and mixtures, an intersection of mathematics and what we might call early chemistry or physics. This was a man of extraordinary range, a geometer, an astronomer, an observer, a teacher, a writer. And then, silence. After those 2 astronomical observations recorded around 98 AD, Menelaus disappears from the historical record. We do not know how he died. We do not know where he died. We do not know if he died in Rome or returned to Alexandria or traveled somewhere else entirely. He simply stops appearing. The light goes out. And in the centuries that followed, the Mediterranean world he knew would convulse and transform beyond recognition. The Roman Empire would fracture. The great library of Alexandria, already damaged by fire during Julius Caesar's time, would suffer further losses and eventually fade. The classical world that Menelaus had inhabited would gradually collapse under the weight of migration, war, political chaos, and the slow, irreversible shift of civilizations. In such a world, books perish, scrolls rot, knowledge disappears as surely as the people who created it. And this is where the story of Menelaus becomes something almost unbearably poignant. Because his greatest work, the Spherica, nearly vanished from the face of the earth. The Spherica of Menelaus was written in Greek, and at some point in late antiquity, the original Greek manuscripts stopped being copied, stopped being read, stopped being preserved. They were lost. If the story had ended there, if history had taken its most brutal path, we would never have known about Menelaus's theorem. We would never have known about his spherical triangles, his astronomical precision, his revolutionary vision of geometry on a curved surface. He would have been another ghost, another name swallowed by the darkness between civilizations. But history, sometimes, is merciful. During the Islamic Golden Age, roughly between the 8th and 13th centuries AD, Arabic scholars undertook one of the most remarkable intellectual projects in human history. They systematically sought out the great works of Greek mathematics and science, translated them into Arabic, studied them, and built upon them. The Abbasid Caliph Harun al-Rashid and later his son al-Mamun founded the Beit al-Hikmah, the House of Wisdom, in Baghdad. This institution became the greatest center of learning in the medieval world. Translators there worked feverishly to render Greek texts into Arabic before they were lost forever. And the Spherica of Menelaus was among them. The Arabic translation, made by scholars including Abu Nasr Mansur ibn Arak and later refined by others, preserved Menelaus's work when the Greek originals were gone. Arabic mathematicians read the Spherica with reverence and excitement. They extended it, they improved on it. Scholars like al-Biruni and Jabir ibn Afla built directly on Menelaus's spherical geometry in developing the full discipline of spherical trigonometry. Without those Arabic translators, without that extraordinary act of intellectual preservation, the name Menelaus might exist only as a brief footnote in Ptolemy's Almagest. Instead, his theorem lives, his ideas live, his geometry lives. The Spherica eventually made its way back to Europe through Latin translations of the Arabic versions, the long, winding road of knowledge that crossed from Greece to Rome, to Alexandria, to Baghdad, to Toledo, to Paris. It is one of the most remarkable journeys a book has ever made. You might be wondering, all of this happened 2,000 years ago. Why does it matter today? Let me tell you. Every time an airplane crosses the Atlantic Ocean, the pilots and navigation systems are using great circle routes, the paths on the surface of a sphere that represent the shortest distance between 2 points. The mathematics that describes those paths flows directly from the tradition of spherical geometry that Menelaus pioneered.
Every time a satellite is launched into orbit and its trajectory is calculated, engineers are working with the mathematics of spherical surfaces. The equations they use trace a lineage back through centuries of mathematics, and Menelaus is near the root of that tree. Every time astronomers map the positions of stars and galaxies on the celestial sphere, that imaginary globe of the sky, they are working in a tradition that Menelaus helped found. And Menelaus's theorem itself? It is still taught in advanced geometry courses today. It appears in the study of projective geometry. It appears in the mathematics of computer graphics, where calculating how lines intersect surfaces is a daily practical necessity. 2,000 years old, still working, still useful, still true. That is the nature of mathematics. The truths that human beings discover do not age, they do not expire, they do not go out of fashion. A theorem proven in Rome in 98 AD by a man looking up at the night sky and watching the moon swallow a star is still valid today. It will be valid in 1,000 years. That is what it means to discover something real. I want to pause here for a moment, not to look at mathematics, but to look at the man. We know so little about Menelaus as a person, and that should trouble us, that should sadden us. He was a real human being. He was born somewhere in the Roman world, almost certainly in or near Alexandria. He had a childhood. He had teachers who sparked his imagination. He had, at some point, the extraordinary intellectual experience of seeing, truly seeing, that Euclidean geometry was only part of the picture, that the flat world of Euclid was a special case, that the real world, the curved world, the spherical world, demanded something more. He traveled to Rome. He stood in that city of marble and power, a city that valued soldiers and senators far more than mathematicians, and he looked up at the night sky, and he measured, carefully, precisely, patiently. He wrote his books, he made his observations, he did his work. And then he disappeared. No grave we can visit, no monument bearing his name, no portrait, no statue that we know of. Just the mathematics, just the theorems, just the Spherica. And perhaps that is enough. Perhaps for a man like Menelaus, that is everything. He wanted to understand the shape of the world, and he did, and he wrote it down. And against all the odds of history, against fire and war and the collapse of empires, his words survived. They survived because truth is harder to destroy than stone. Now, I promised you something. I told you at the beginning of this video that there was a striking, almost unbelievable detail about Menelaus and his legacy, a detail that would change how you see the survival of human knowledge. Here it is. Not a single word of the Spherica survives in Greek. Let that register. The language Menelaus wrote in, Greek, is a language we can still read. The Greek of the 1st century AD is well understood, and yet the original text of the Spherica, the very words that Menelaus wrote with his own hand on papyrus scrolls in Alexandria and Rome, those are gone, completely and irrecoverably gone. Everything we know about Menelaus's Spherica comes from translations. First from Greek into Arabic, made in the Islamic Golden Age, sometimes through an intermediary Syriac version. Then from Arabic to Latin, and later into European languages. This means that historians and mathematicians studying Menelaus are always working at one or two removes from the original. They are reading a translation of a translation and trying to reconstruct what the Greek original must have said. And here is the truly stunning part. The Arabic scholars who translated and preserved the Spherica did not merely copy it mechanically. Some of them, like Abu Nasr Mansur ibn Arak, working around 1000 AD, actually improved it. They corrected what they believed were errors. They added clarifications. They extended the proofs. So the version of Menelaus's work that came down to us is in a very real sense a collaboration, a dialogue across 9 centuries between a Greek mathematician and Arab scholars who admired him enough to rescue, refine, and amplify his genius. The Spherica is not purely Menelaus. It is Menelaus filtered through the minds of those who loved him enough to save him. Does that diminish Menelaus? Not for a single moment. His core ideas, his theorems, his revolutionary vision of spherical geometry, all of that is his, and it is verified by the internal consistency of the mathematics and by independent references in Ptolemy and others. But it adds a layer of beauty to the story that almost takes your breath away. Human knowledge is not a solo performance. It is a relay race across centuries and civilizations, and sometimes the baton must be passed through translation, through devotion, through the loving hands of strangers from a different world and a different faith before it reaches us. Menelaus gave humanity a gift, and humanity, across 2,000 years and several civilizations, chose to keep it. Menelaus of Alexandria. Born around 70 AD into a world of empire and intellectual fire, a man who looked at the flat world of Euclidean geometry and dared to ask, what about the sphere? A man who made precise astronomical observations under the Roman sky, who wrote the first surviving treatise on spherical trigonometry, who proved a theorem so clean, so elegant, so true that it still stands in our mathematics textbooks 2,000 years after his death. A man whose words were lost in Greek and rescued in Arabic, whose genius was saved not by his own civilization, by scholars from a civilization that had not yet been born when he was alive. That is the story of Menelaus. Not just a story about mathematics, a story about what it means to leave something behind that matters. A story about how fragile knowledge is and how fiercely human beings across every culture and every century have fought to preserve it. The next time you take a flight that arcs across the globe on a curved path, the next time you see a satellite trajectory on a map, the next time you hear the word trigonometry in a classroom, remember Menelaus. Remember the man who first mapped the geometry of the sphere, who gave the stars a language, who asked the right question at the right time, and whose answer echoes still in every calculation we make about the shape of the world. If this story moved you, if you felt the weight of what it means for a single human being to change the course of science, then please do these 3 things right now. 1. Hit the like button. It takes 1 second, and it tells the algorithm that stories like this one deserve to be seen. 2. Subscribe to Numbers and Narratives by Blessright and ring that notification bell so you never miss a story about the extraordinary human beings behind the numbers that shape our world. And 3, share this video with someone who loves history, mathematics, or science, someone who deserves to know the name Menelaus. Because these stories deserve to be told, and they deserve to be heard. Until next time, keep counting, keep questioning, and keep looking up.